Welcome back, mathletes. We're talking about implicit differentiation, round 2. All right, mathletes, so let's go ahead and let's find dy dx, right, by implicit differentiation. All right, so we know the drill. This problem's a little bit more involved, a little bit more complicated, but we got this. All right, so we're gonna take the derivative of both sides here. All right, so let's go ahead and derive both sides like it's 1999. All right, so there's our notation telling us and our readers that we're going to derive this mother sucker. All right, so because we have a subtraction here, we have two terms, we're going to go ahead and derive each one of those. All right, so let's do that. And let's write this out, right? A lot of writing, so make sure do your finger stretches. A lot of writing going on.
It's just going to be taking your thumb and tapping it to each finger. So almost just closing a loop and going back and forth. Really opening back up each time you touch.
All right. And then we're going to take the derivative of that second term. Newsflash, newsflash. For this term right here, I don't know if I like that gray. Let me change it. Let's get some yellow going on. For this second term, notice we have a multiplication going on. So in the back of your head, what I want you thinking about is we are probably gonna have to use the product rule here. All right, so let's continue. And then, I want black. And then we're gonna take the derivative of this. And because it's just one term, shoot, let's just take the derivative of it. So the derivative of negative 7y with respect to x is going to give us negative 7, right? We could bring that negative 7 to the front, and then we're just going to take the derivative of this y term, and which is going to give us dy dx. All right, because we remember y is some function in terms of x. So I probably have something over here that has, I'm just going to pretend this is not it, but I'm just going to pretend it's some equation that's going to have x, the variable x, because we're finding dy dx, right? It's going to have x on the other side. Again, I don't know what this equation looks like, and because I don't know, all I tell my audience is, well, whatever it is, I'm going to take the derivative of it, whatever it may be, all right? So that's where we're at. All right, and let me get rid of this before it does more damage than good. So let me erase that. All right, so now let's get to it. Let's go ahead and take the derivative of every single piece here. So I'm going to take the derivative of this term, and we already took the derivative. So let's move you over here, Johnny, and let's do this. So the derivative of 2x with respect to x is just 2. All right, so that's that derivative. Minus, we said we're going to have to use, right, we have a multiplication. We have to use the product rule for derivatives. And if you forgot how to do the product rule, then go ahead and click my video right there, and that'll help you out. All right, so let's start it off. I'm going to call this piece, this factor, I'm going to call that the f, and I'm going to call this factor g. So I'm going to say x to the fifth represents the f, the function f, and y squared is going to represent that function g. All right, so here we go. So according to our product rule, we're going to take f, we're going to take f and we're going to multiply it by, so this was f, let me write that down, this was f, and we're going to multiply f by g prime. And because it's we're going to see addition for the product rule, the order doesn't matter. And so g prime, we're going to take the derivative of y squared with respect to x. And this is where we have to be careful, right? Because we're not just taking the derivative, but with respect to x. So let's see what the heck's going on here. So I move that 2 to the front, and I get 2y times the derivative of that function, or y, that equation y here, with respect to x. Because again, we don't know what this equation y equals looks like. So what we do is we tell our audience, whatever that equation looks like, we're going to take the derivative of that equation. All right? And then we go ahead and continue. Plus, now we take the derivative of f, right? So we're going to take the derivative of f, which is x to the 5th power. So taking the derivative of that, we end up with 5x to the 4th times g, which is just y squared. All right, so there's our product rule right there. And then let me bring down what we didn't use, -7 dy dx. All right, so let's go ahead and distribute this negative, right? This negative right here, right? So distributing it, let's clean things up a little bit. We get 2 minus x to the 5th. I'll bring the 2 to the front. So 2x to the 5th y dy dx. And this next part, I really want you to pay close attention and be careful, because usually it's the little algebra mistakes that get us. In fact, here's a little secret. I had to re-record this whole video because I did all this work. I finished this problem, and then I was watching it for edits, and I was like, wait a minute. And I noticed in this next step, I forgot to distribute this negative also to that 5, and it jacked everything up.
You blew it!
So again, one little mistake, right? One little mistake, could waste a lot of time. So be very careful as you're going through this, all right? Because it happens to the best of us. All right. So I'm going to distribute that negative, and we're left with -5x to the 4th y squared. And of course, that still equals -7 dy dx. All right. So always remind yourself of, what I'm doing, because these are a lot of steps, and you always have to stay focused in terms of what's the mission here. And our goal, right? Our goal is to isolate, right? To solve for, to isolate dy dx. So that's what we're solving for. All right, so keep that in mind. So let me go ahead and do some YouTube magic here, and let me cut this, and let me paste it onto our next clean page. So let's start a new page. All right, let's move that to the top here. All right, and this wouldn't be a video without your host. So here's Johnny. All right, so we want to isolate dy dx just like we said. So we have to decide on is what side do you want dy dx on, and it truly doesn't matter. So let me go ahead and let me take this term right here, and I'm going to move everything over to my right hand side. Again, because I want every term that has a dy dx, I want it on one side, because that's what I'm solving for. All right, so let's go ahead and we move that over. So what are we left with? We're left with 2 minus 5x to the 4th y squared, and that's all equal to -7 dy dx plus 2x to the 5th y dy dx. All right, so now we're trying to isolate dy dx, but right now we have 2 of them. So notice, I just want one. So we could see here, since they have a dy dx in common, well, we could just factor this out. So let me highlight, right? This is what they have in common. So this is what I'm gonna factor out. So I'm gonna factor out, I don't want that. I'm gonna factor out a dy dx. So when you factor out the dy dx, you're left with that -7 plus the 2x to the 5th y, right? And that's still equal to 2 minus 5x to the 4th y squared. And last step, right? Our last step, our goal is to isolate dy dx. So we're going to go ahead and divide. Oops, there I go again. Divide by everything that's not dy dx. So we divide by -7 plus 2x to the 5th y. And we'll do the same exact thing to our other side. -7 plus 2x to the 5th y. And now we have done it. We have isolated, we have solved for dy dx. And so we end up with, instead of copying this down, let me just do a little copy and bring it down because I'm a little lazy. All right, folks. So just follow those 203 steps and that's it. All right. So hopefully that was helpful. This problem was a little bit more complicated, but stay patient, right? And always look for those little things, because those little things, you mess one up and that's going to jack everything up. So again, make sure you don't drink and derive. And I'll see you in the next video. Don't forget to like, subscribe, and I'll see you next time, gang.